Good morning, students. So, after a small break, once again, welcome to the topic on operation research. So, in the early class, we discussed about the continuity of nonlinear programming algorithm. We have discussed to solve the nonlinear programming algorithm in two categories. So, one is without constraint, that is unconstrained, and the other one is with constraint, that is constrained algorithms. So, in the early class, we discussed the various methods that we are discussed in under the category of the unconstrained algorithms. Now let's move to how to solve the constrained algorithms. Here we are going to discuss mainly the two methods. So one is talking about the separable algorithm method. That is, one can split the given function to talk about their objectiveness into small pieces of functions. Then we start analyze about that function. Then we conclude a global level a given objective function. So this is the concept of talking about the separable algorithm. So what is a separable programming means? A function is said to be a separable if it can be expressed as the sum of n single variable f1 of x1, f2 of x2, and so on fn of xn. That is, f can be expressed as the sum of the n number of functions involving on n variables. We discussed some examples in the classes also. The functions are which are separable and which are non-separable functions. Maybe you are all remember the concepts. Now, based on this concepts, now let's move to the example to solve the separable programming algorithm using the approximation concepts. Let's see some example. Let's start with the example. For a given function z, their maximization is x1 plus x2 to the power 4 subject to the constraint 3x1 plus 2x2 square less than or equal to 9, x1, x2 are greater than or equal to 0. Now, how to solve this one? From the given objective function, we can observe that if I consider the function like this, function involving x1 as f1 of x1 and function involving on x2, that is x2 power 4 as f1 of x1 and f2 of x2 respectively. Similarly, from the constraint, the x1 variable is nothing but g1 of x1 as a function 3x1 and g2 of x2 as 2x2 squared. Now one can clearly observe that the f1 of x1 and the g1 of x1 are a linear function. Once it is a linear function, then we have no need to solve about that the approximation concept because it is a linearity. Therefore, we have to concentrate only the non-linearity functions f2 of x2 and g2 of x2, right? So that we can make this function into linear form. So therefore, we are going to consider the f2 and g2 into a linearity form. We observe the boundness. How do you think it about the boundness of this functions? From the constraint, from this constraint, if I take x1 equal to 0, then 2x2 square is less than or equal to 9. So from here x2 square is nothing but square root of 9 by 2, that is nothing but 2.1. So similarly, if I take x2 is 0, then we'll get 3x1 is less than or equal to 9. So from here x1 is less than or equal to 3. So anyway, we observe that these variables are bound between 0 and 3 because this x1 and x2 both are positive, that is greater than or equal to 0. So here the maximum is 3. Therefore, we have to consider the breakpoints, right? So in the intervals from 0 to 3, we'll put as 0 to 1 and 1 to 2 and 2 to 3, and we'll consider this interval as 0 to 1 as 1 and 1 to 2 as 2 and 2 to 3 as 3 and the 3 to the that is k is 1 2 3 4 and the interval is 0 to 1 and 1 to 2 and 2 to 3. So there are 4 points we have to consider, right? So here the condition is this one: aj1 must be strictly less than aj2 and strictly less than aj3 and strictly less than aj4. These are all nothing but talking about the breaking points. So here we are consider as j equal to 1 and 2. What is j equal to 1 and 2 means? There are number of variables, right? So x1 x2, that is j equal to 1 and 2. So from here we observe that it is enough considering only 2 j equal to 2, because we already observed that x1 is a linear function, right? Therefore only we have to consider j equal to 2. Therefore that's why I take a to k. So put k equal to 1 2 3 and 4 and we observe that a21 has 0 and a22 is nothing but 1 and a23 is nothing but 2 and a24 is nothing but here this 4, right? Sorry, 3. This is wrongly put it. This is not 4, this is 3. So all those things here we are reflected, right? So k is 1 to 4 and a to k is 1 0 1 2 3 arms, right? Now what is the things? We have to go for this f to x2 power 4. So in the place of x2 I replace the breakpoints by a to k. So here similarly the right hand side a to k to the power 4. So you replace this a to k by 0, then 0 to the power 4, that is 0, and by 1 it is 1 to the power 4, it is 1, and by 2 it is 2 to the power 4, it is 16, and 3 to the power 4, it is 18. So similarly g to a to k, that is 2x2 square. So here also you put in the place of a to k is 0, so 2 into 0 square, that is 0, 2 into 1, that is 1 square, so it is 2, again 2 into 2 square, that is 8, so 2 into 3 square, that is 18. So using this table, now we express this function f2 and g2 in terms of the breaking points, right? So that is wjk. So it's a formula from the separable algorithm that is discussing like this: fj of xj is expressed as the sum of the wjk into fj of ajk. So this is the reason why this is called separable approximation algorithm, right? So we are approximating the function, right? So that's why I will put it here. So now you take j equal to 2 and vary the k equal to 1 to 4 onwards. We'll get f2 of x2 is like this: w21 f2 of a2k, w22 f2 of a22, and so on like this up to 4. Now the thing is what? I have to substitute all these values: f2 of a21, f2 of a22, f2 of a23, and f2 of a24 from this table. Substitute here, right? So he'll put it: f2 of a21 is 0 and 1, 16, 81. Simplify this. So f2 of x2 is nothing but w22 plus 16 w23 plus 81 w24. So similarly we can go for g2 of x2 also, right? The same way, same concept, right, as we are discussed in the f2 of x2. So we observe that g2 of x2 is nothing but this is the thing. So 2w22 plus 8w23 plus 18w24. So concluding all these things with changing or rewriting the given objective function is like this, right? So the maximizing set is equal to x1, because already we observed it is a linear, therefore we are not disturbing that one. The remaining things x2, that can be put it like this, right? x2 we already observed, that one will substitute. So this is f2 of x2, right? That is nothing but x2 terms. That one after suitable modification, these are the things we observe. Therefore we will substitute all these things here, right? And plus these two are we can observe from the given constraint, right? So from the given constraint we observe that uh, right? So the constraint is what? This is the thing. So 3x1 plus 2x2 square less than or equal to 9. So we already know it in a simplex method. If it is less than or equal to 9 or boundless, you should add something on the left hand side, that is called a slack variable, so that this is getting as equality, right? So that is the things. So here we will put it the constraint 3x1. Again, we already know it. It is a linearity. I am not disturbing that one. The remaining part x2 terms, that one from this case, we'll paste it here. And because we need to get the identity matrix, we need to introduce another slack variable s1, and the artificial variable we consider as a w21, right? So we need the identity matrix. That's why we'll put it. So s1, if you take the slack variable, then it is the inequalities become equality, right? And one more condition from the separable algorithm method, right? So that is summation of wjk, that is the breaking point must be equal to 1. So that is the condition, necessary condition. So that is, if I take j equal to 2 and vary the k values, it is equal to summation is equal to 1, right? So put all together, we have to form the simplex table to solve this case. So here some other methods is also available, but here we are going on the simplex method concepts, right? So this simplex method concept here, before moving to simplex method concept, there is some assumption under this algorithm. So what that method is? The first assumption is, for each j, no more than 2 wjk are positive, right? So that is wjk we should not consider more than 2 as a positive. So that is the first condition. Next condition is, if suppose there are 2 wjk are positive, then it must be adjacents, right? So what is adjacent means? For example, here according to the previous observation, w21, w22, w23 and w24. So here w21 and w22 are adjacent, but w21 and w23 are not adjacent. w21 and w24 are not adjacent. So that is the meaning, right? So under these two assumptions, we are proceed further for a given objective functions, and with constraint we put it in the simplex table formats, right? We are already familiar that case. So from this first constraint, we'll put all these coefficients, right? So naturally, I have to take this S1, right? Because we always concentrate the slack variable and artificial variable. So here we'll put the basis variables are slack variable and artificial variable, right? So their corresponding values are 9 and 1. So that one also will put it. Their corresponding coefficient here 0 and 0. That is the things here we'll put it, right? And from the first constraint, their corresponding coefficients of x1, w21, w22, w23 and w24, and s1 here we'll put it, paste it. Similarly, from the second constraint, we observe that all these coefficients here we'll put it, right? And from the objective function here, the coefficients are here, right? 1, 0, 1, right? So all these coefficients here we will put it. Now, as usual, what is the things in the simplex method? We have to take the products, right? That is computing zj. So what is zj means? Nothing but the cb into corresponding the column. Here sum it up, product it and sum it up, right? So 0 into 3 plus 0 into 0, that is zj. So similarly 0 into 0 plus 0 into 1, that is the thing here. Similarly do 2 into 0 plus 1 into 0, sum it up, so it is 0. So likewise, all the values of zj will get it 0 because the thing is here zeros, right? Now the next one is zj minus cj, right? So that is this one minus this one, right? So that is minus 1. So 0 minus 0, 0. So 0 minus 1, minus 1. So 0 minus 16, minus 16. Like this, we will get all this zj minus cj. Now the natural thing is what? In simplex method. So when I can stop the table until we will get zj minus cj are all positive. But here the thing is what? There is the case, not the case here, because there are 3 negative values are appeared here. So the next one is what? I have to choose the pivotal column, right? How do you choose the pivotal column? I have to choose the most negative value among this zj minus cj. So here minus 81 is the most negative value, right? So therefore this is the pivotal column, right? From this I have to choose the pivotal row. How do you choose the pivotal row? That is the xb divided by pivotal column. So that is 9 divided by 18, 1 divided by 1. So among these I have to choose the minimum, that is the ratio, right? So 9 by 18 that is nothing but 1 by 2, and here 1 by 1, that is nothing but 1. So therefore 1 by 2 comma 1, the minimum is 1 by 2. In other words, this is the pivotal row, right? This is the pivotal row. Therefore this must be the living row, right? In other words, W24 is the W24 is the entering variable and S1 is the outgoing variable, living variable, right? But the condition according to the assumption, if suppose W24 is entering here and S1 is outgoing, but think in this case, the condition W24 is not adjacent to the W21, right? So W24 is not adjacent to W21. If suppose W24 is entering, then W24 is not adjacent to W21, right? So it violates our assumption that the WJK should be a adjacent points, right? So that is W24 and W21 are not adjacent. So what is the meaning? So it violates our assumption. Therefore, this is not the our pivotal column. So therefore, I have to move for the next most negative value. So the next most negative value is minus 16. So you proceed the same way, right? So this is our pivotal column, and you choose again as usual the theta ratio. This is the pivotal row and this is the pivotal element, right? And if you check it, all the conditions are acceptable. The reason is what? Because this 9 divided by 8 and 1 by 1, if you choose it, it is 1. So this is the pivotal element. Therefore W23 replace the W2. So it is acceptable, right? It does not violate any of these two conditions, right? So therefore W23 replace the W21. So what is the next things in simplex table? I have to make this pivotal element become 1 and the remaining entries in the pivotal column should be make it as a 0, right? So how do you do that one? That is, I have to make this entry should be 0, right? So what I have to do? So here already 1 is there, pivotal element. Therefore, no need to take any modification, right? So simply just multiply this entire row by minus 8 and add with this row, so that this entry will be become naturally 0, right? So that is the things we proceed further, right? So here we can observe, right? So that is W21 replaced here by W23, right? And this entries became 0, right? So same things, operation, entire things go for this, right? So you will get the new simplex table. Now again, we have to continue the same way, right? I have to choose the Zj and Zj minus Cj. Again, among Zj minus Cj, I have to choose the most negative value, right? So here, the most negative value is minus 65. Therefore, this is the pivotal column. Again, as usual, 1 divided by 10, 1 by 1. So among these two, the minimum is what? 1 by 10. Therefore, this is the living row, right? Pivotal row. And this is the pivotal element. So therefore, what is the meaning? This W24 is the entering and S1 is outgoing, right? S1 is outgoing. Is it acceptable? Yes, it is acceptable. Because the thing is what? This W24 is adjacent to W23, right? So therefore, as per the assumption, we can proceed further, right? So that is as usual. The next thing is what? I have to make this entry become 1 and the remaining entries in that column should make it as a 0. So therefore, how do you make it? This entry is pivotal element became 1. Just divide by 10, right? So 10 divided by 10. Therefore, this entry is become 1. So same operation should be do for the entire row, including this basis value, right? So therefore, that is the things here we have done it. 1 by 10, 3 by 10, minus 8 by 10, all those things. Now the thing is what? I want to make this entries become 0. So how do you make it? So this new row minus the old row of W23, right? Simply enough, no need to take any operation. So simply this entry minus this entry, so that this entry is become 0. So therefore, this one minus this one. So this is 0. So same things will be, we have to proceed for the entire row. So you'll get this a nice entry, right? Nice entry. So the next one is what? The thing is, as usual, again I have to check it the most negative value appear or not. Yes, it is, the negative values appear. So therefore we have to proceed further. So what is the next one? I have to choose the most negative value. So here the among these Zj minus Cj, the most negative is minus 36. So I have to choose this is the pivotal column, right? So I choose the pivotal column is W2, right? So this column is pivotal column. Now the next one is what? I have to choose the pivotal row, how do you choose it? The basis value divided by the pivotal column, right? So 1 by 10 divided by minus 8 by 10. So it is negative, therefore we should avoid it. So in the simplex table, you know, you are all familiar. So if it is negative is there, then I have to avoid that part, right? So therefore I have to go for here. So 9 by 10 divided by 18 by 10. So this is the only option. So no need to go for talking about the minimum. Therefore this is the pivotal row, and this is 18 by 10 is the pivotal row. Now the thing is what? W23 replaced by W21. But as per our assumption, what? If you replace it, then that point should be adjacent to the other one, right? So that is W21 should be adjacent to W24, but it is not the case. W21 is not adjacent to W24, right? So W21, if suppose replace the W23, then W21 is not adjacent to W24. Therefore, it is violating our assumption. Therefore, we have to move for the next most negative value. The same thing here. Again, this is the negative. Therefore, this is the only option. Again, 9 by 10 divided by 16 by 10. So this is the only option. So therefore, this is the pivotal row, and this is pivotal column, and this is the pivotal element. Again, the same concept. W22 replace the W23. Again, W22 is not the adjacent to W22. Again, it violates our the norms. Therefore, what is the conclusion? The conclusion is there is no further movement under this situation. So in other words, this will give the optimum value for a given objective function, right? Because only these two are the negative, the remaining things are positive. So but for both these two cases, it violates our assumption. Therefore, the thing is what? This is the final table. We will get the optimum value. So I'll stop here. The thing is what? I have to proceed with these two values. That is W24 is 1 by 10 and W23 is 9 by 10. And what about the remaining things? Naturally, W21, W22 are all 0, and further X1 is also 0, right? Now using all these value, we have to substitute in the given objective function with these things that we already know, right? So xj is what? Nothing but summation of wjk, that is approximation into ajk, right? So x1 from the table we observe it is 0 because it is not appeared in the basis variable. Therefore x1 is 0, and x2 according to this case, if you expand it like this, and we observe that there w23 and w24 are exist, remaining things are absent, right? In other words, that are all zeros. Therefore w21 0, w22 0, that's what I'll put in. And the a21, a22, a23, a24 all we can see from the previous the initial tables, right? So substitute all these values, simplify it, you'll get 2.1, that is 21 by 10, it is nothing but 2.1. So that is x1 and x2 are we are getting. Now substitute all these things in the objective function, that is x1 plus x2 power 4, right? So in the place of x2, I'll put 2.1, in the place of x1 it is 0. So simplify it, right? You'll get 19.45, right? Now this is the things, the maximum value for given function is, right? So this is one of the nice example. So again, similarly, the based on this concept, next we move for separable convex program. So we will see in the next lecture. So I hope you can understood the problem on separable programming algorithm, right, based on the approximation concepts, right? So in the next class we discuss the same thing, separable approximation in terms of the convex, right? So we'll see in the next class. I hope so you all enjoy the lecture. So if there is any clarification, I can always free to clarify your doubts, right? So if possible, we can meet in the class, right? So I'll stop here, students. So don't hesitate. Is there any clarification you can mail to me, right? So let's see in the next class. So thank you, one and all.